All right, so let's get started. So thank you for being here. Obviously, our numbers are much lower. Like, took the summer school over for some classes. That's maybe that might be it. But I'll probably have to send a reminder or say, hey guys, we're still meeting. So yeah, so thank you for doing that assessment too. So this is from the May 2017 exam, and you guys did not the whole math. You guys did the first 11 questions for section 3 with math without a calculator. You guys did the first 21 questions for math with a calculator. There's still 4 more multiple choice questions you guys didn't see. Maybe we can talk about that later today. And then the free response questions I didn't have you guys do. For the math with a calculator section 4, there were 9 multiple choice questions I didn't give you guys, 22 to 30. And then of course there are 8 free response questions. So I did do a little tally. And what I'll do is I'll probably go over the questions where I think most people miss questions. And I think maybe guys, if there's a lot of people miss like the same questions, it's probably because it's a concept we haven't taught you guys yet, like stuff with advanced algebra, which would make sense that if you had Algebra 2 last year, we didn't have the most ideal schedule for math, especially in the spring semester. And also, or if you had Algebra 2 in the spring of 2020, when the pandemic hit us fast and hard, yeah, I mean, I taught Algebra 2, we didn't cover everything. Like we had to cut stuff out. Or if you had, pre-calculus last year, but again, things that be patched together. So I do think there's some advanced questions you get. Like for example, number 11, I think everyone missed number 11. That's a great question for us to go over. So I'm just going to kind of go through like the beginning and kind of talk about questions that gave you guys trouble. And I'm actually going to do it from my desk here. I'm recording this on Zoom, and I have to use my mouse. So I wish I had my podium. I should have grabbed one from another room. But if you have questions, let me know. But I'll just kind of work through some personal. I just want to make sure I'm recording for people who want to watch at home later. So and also there's some questions in the fourth section, section 4 of the math with the calculator. There's some concepts we just haven't even taught you guys. Like we don't teach it. Pre-pandemic, post-pandemic, doesn't matter. There's some statistics, like some graphics that, yeah, we just don't cover in high school level. But somehow you're supposed to somehow know or learn it. So I'm going to talk about it with you guys too. So this is actually good because this kind of tells me what direction I want to take going forward. And I did print a whole bunch of packets on advanced algebra that we could talk about in the second half of class today. So that was kind of my thinking where you guys probably need the most support. So anyway, without further ado, and if you have other questions, please let me know. If I didn't go over a particular question, say, okay, please go over this question with me. So I'm going to start with number 4 of section 3. That's a question that had a high frequency of misses among you guys. And really, whenever you see a lot of words, to be honest with you, just read the last sentence and just see what they want. What do they want? They want, basically, they say the quantity demanded and the quantity supplied are given by the equations above. What is the equilibrium price? Okay, what is equilibrium price? They want the equilibrium price. What is the equilibrium price? It's defined when the quantity demanded equals the quantity supplied. So basically, it's when these two equations equal each other. That's what they want. They want you to set these equations equal to each other. That's all. So 60 minus 3/4 p equals 1/4 p. So we see p occurring at 2 places, right? One time on the left side, one time on the right side. So we combine them. How do I combine them? Just add 3/4 p to both sides. If you do that, obviously these go away. So you're just stuck with 60 on the left side. On the right side, what's 1/4 plus 3/4? 1. So 1p. There you go, done. $60. That's all. Or you can work backwards. You could just test the choice. Like, what if I plug 0 in for p into each equation? Are they the same? No. If I plug in 60, I do get 15 to 15. So that's another way you could approach it as well. Let's take a look at 7 next. 7 is another one that some of you missed. It's a little weird, and I'm going to kind of give you so for me, I kind of instantly know what to do, but again, I've done this for 20. I'm actually approaching my 20th year of doing tests, right? I started actually when I moved back to the Bay Area in September 2001. Yeah, I was much younger then. But yeah, when I look at this, here's why I know what to do. I'm just going to multiply 13 by 2. And the answer is 26. So I got that in the blink of an eye. How did I know to do that so quickly? What about this problem made me think to do 13 times 2? If you take a close look at this expression here, let me highlight it. And take a look at these expressions. How are all those related? Like, how would I combine x plus 1, x minus y? If I combine those two, kind of. What you're doing is you're gonna do FOIL. So you guys might remember this, and you guys have done this. It's just the things you've never seen a problem designed like this. But you have FOIL before. I know you have, and I know you did it in middle school. So x and x is x squared. X and negative y is negative xy. Y and x is positive xy, and of course y and negative y is negative y squared. You see how the middle terms cancel, negative xy and positive xy? They cancel it very nicely. What are you stuck with? X squared minus y squared, which is what the question wants. So it seems as if I could just multiply x plus y times x minus y, which is 13 and 2. That's how I get 26. Now, if you want to solve for x and y separately by using like substitution, elimination, so Jill, I know you said substitution, right? Yes, you could have done that. That's just a little more time consuming. But yes, you could have, or you could have done elimination by adding the two equations together, solving for x. And then once you get x, you can get y, then move from there. I suppose that could have worked too. But I would much prefer to actually get a little more creative here. And again, how did I know to do that? Just practice. And I'll trust me, I'm going to give you guys practice on this stuff so that you guys can see more of a commonality. And again, you guys only this is like only our 4th or 5th time. And you know what, your exposure is a little more, I mean, I do test prep like 6 to 7 hours a day, pretty much 40 to 50 weeks a year for 20 years. Do the math. And that's a long time. So you guys are still just kind of, and again, like you really once you get to about like 3 months of this kind of stuff, you guys will totally feel ready. So, and I know some of you guys are doing this test later in the fall, so you will have that experience. But I'm just telling you that these are very common questions. Let's keep moving. Another one I noticed was, let's look at 11. That's actually, let's do 8 and 11. Let's stay on the same page. Let's do 8 and 11. So let's stay on the same page. Let's look at 8. Okay, again, a lot of words. Let me read the last sentence. Was the least number of loaves of bread Bob needs to sell every Saturday to cover the cost of the vendor's fee. Okay, so he needs to sell just enough to break even, right? That's what they're trying to talk about. So now let's look at the information. A loaf of bread costs him $1 to make, and he sells it for $3. That's a $2 profit, right? $2 profit. However, he has to pay a fee to, maybe if he's going to the farmer's market, he's got to pay for the stand, or he's got to pay a fee just to be there. He's got to pay $75 for that. So his costs is $75 plus, we'll say X, where X is number, because X will be the number of loaves, we'll say. And remember, each loaf costs him $1. So that's why I do 1X. Now, what does he collect? We call that revenue. That's what he collects. That's 3X, right? He collects $3. So really, you can just set them equal to each other and solve for X, which you should get 37.5. So it means he needs to sell at least 38 loaves to make sure that he can cover the cost of everything. Or you could have done the profit, which is $2, right? But 2X equals 75. You can do that also. That could work. Again, word problems is a very common thing on the SAT. They love it. Again, just practice, right? Let's keep moving. Let's look at 11 now. I think everyone missed 11. Okay, so it's a tough problem. This is a very common problem. So this is interpreting. We did talk about this last week, or maybe the week before. I call this interpret linear equations. Okay, how do I know this is linear? Look at the choices. First of all, you should be able to recognize this. What is that I just drew? What does that represent? Y equals mx plus b. What is that? slope, and also y-intercept. It's an equation of a line, totally. All the choices are written the same way. P is like y, f is like x. That's like saying y equals 1 over 33 times x. The first choice is a linear function with a slope of 1 over 33. Or let's look at C. C is like saying y equals 33x plus 1. So what this tells me is that f is x, p is y. Now what is f? F is going to be the feet you are below sea level. Okay, fine. So the feet that you're below sea level. What is P? P represents pressure. Okay, all right. Now, do they give some information? Absolutely. They say that the pressure exerted on an object underwater increases by 1 atmosphere every 33 feet below the surface of the water. And at sea level, the pressure is 1 atmosphere. So let me get a highlighter out here. So increases, that's a change every 33 feet. So really, that's a ratio. That's a ratio. What this is telling me is that the pressure, the change in pressure over the change in feet is positive 1 over negative 33. So the pressure goes up 1, you go 33 feet down below, right? Guess what that looks like? That looks like slope. Because this wasn't PY, wasn't FX, based upon the way the choices look, right? So that's going to be my slope. Actually, because feet below sea level is F array represents being below, it's actually a bit redundant to write that minus there. So it's actually just 1 over 33. My apologies. The scientist in me wants me to make it negative, but yeah, but it's already taken care of. This right below sea level. They use the word below, and then here's the other part that helps too. They tell us that at sea level, that means that when you're at sea level, F is 0 because you've not gone below, right? So at sea level, F is 0, which is like X. So that's a y-intercept. I see 1 as y-intercept right here. And here, of course. But I want this, so 1 over 33, that's why it's D. That's called interpreting linear equations. I actually have a packet where I could give this to you ad nauseum. Like, you will be so sick of these problems. But I will give you as much drilling as you need on this because it is a very common theme. But I think this is important. So, and also me as a calculus teacher, we talk about interpreting slope all the time. Some of you guys might be taking calculus in the fall. Some of you might be taking calculus in college. It's just a good skill to have to be able to interpret linear equations and understand what slope is in context of a word problem. So that's kind of all I want to go about with section 3 before I go on to section 4. So I did go over 4 problems here. I went over or 3 problems actually. No, wait. No, I did 4 problems, 4, 7, 8, 11. What are the other ones you guys want me to go over before we move on to section 4? If you have any other questions like later in the class, just ask. I'll come by and check in with you. Okay, now let's talk about section 4. Oh yeah, go ahead. Yeah, go, Sarah. Sure, no problem. I'll go over 10. Oh yeah, 10. Okay. They want you to isolate y. So again, I just instantly gravitated to that last sentence. What is y? Okay, so I want y. I want y. Well, where's y? There and there, right? So y is in 2 places. So I better collect them on one side. So that's what I'm going to do right now. I'm going to collect them on one side. So w, come on. wxy minus wx equals yz minus xyz. So what I just did was I collected all terms out y on one side. I know that we've gone over this problem in Algebra 2. We usually do in the beginning of Algebra 2. But again, you know, just we didn't have the most ideal situation of teaching math over the last 16 to 18 months. If you factor out y, you get this. And of course, the other side is what it is. And then you can move things over to the other side. Make sure I'm doing this correctly. Hold on a sec. Oh, okay, I'm an idiot. How many times will y occur? Not just twice. Yeah, my bad. Okay, well, take two. My apologies. Let's try this again. I'm going to move the yz from right to left and keep everything else where they are. The reason why I knew I did it wrong is because I didn't see any choices that was going to work for me. And here's the thing. I didn't like lose faith. I didn't say, well, I don't know how to do this problem. So this is a soft skill. It's not about math or about, being intellectually, at the high end or anything like that. It's really just resolve, right? Just like being determined, like persistent, like, you know what, like I know my math. I'm confident in myself. So I'm not going to say, well, I just don't know how to do this problem. I'm just going to give up. No, like I know I made a mistake. I didn't see why. So I just went back, did a double take and said, okay, now I feel better about this. Now let me get y by itself. So you need to just tell yourself the same thing. Like, you got this, you know this. Don't give up. Just keep trying. Okay, now I feel better because I have wx on the right side. I factor out y to get all this junk. D looks like a good answer to me. And there you have your answer there for that one. Now, they did put C as a trap. Some people might think to cross those off. Don't do that, please. Don't cross off the wx's. There's a plus connected to wx and all the other junk. You can't cross this. It's like saying if I have 4 over 4 plus 5 plus 6, I can cross all those 4s? Absolutely not. You cannot do that. That's just 4 out of 15. You leave it as is. It's tempting to do that. You could do that when there's a times. When all these are multiplied, sure, you could do that. Because crossing off is like division, and that's the inverse of multiplication. You can't do it when there's pluses. So they put C as a trap to mess with you, just so you know. So that's just really bad. You don't want to cross off the wx's there. So it's D. Okay. Now let's move on to section 4. So I felt the beginning went pretty well. I think 8 was a problem. So I want to talk about 8 first. Yeah. And this is advanced. This is advanced algebra. We failed you guys. I think every school in the country failed their students with this kind of stuff. If you had algebra pre-calc, because yeah, we just didn't really have a chance to teach it correctly. So let's read it. What do they want? They want the x-intercept. Okay. Now, when you have a graph, let me just draw a graph right here. You guys should know if I have something really funky, x-intercepts are exactly what they mean. Intersecting the x-axis, you touch the x-axis. What are the y-coordinates when you touch the x-axis? Y-coordinate's always going to be what when you're on the 0? Plug in 0 for y. That's all you got to do. And they want to make sure that the x-intercept is a constant in the equation or a coefficient in the equation. So let me plug in 0 for y, which actually should be a very easy calculation. You get x minus 0 minus 0 minus 11. X equals 11. Okay, great. Whichever one shows 11 is what I want. That's it. You do not have to do any crazy algebra here. Just give them what they want. That's it. They want the x-intercept, give them the x-intercept. So it's 11. I need to have 11 in my equation. That's all they want. It's a little cryptic, like what they're at. Because again, I've never asked this question. My 16 years teaching this school, I've never asked a question about parabolas in this manner. I don't think to ask that because that's just not. I'm not interested in checking that skill, but this is what the SAT wants. So that's all. Let's do 9. I think almost everyone missed number 9. Actually, not everyone. There's 2 or 3 of you guys that got right in this room. But here's what we should do. The sum of 2 different numbers, okay, well, fine. X plus y is 70. The difference when the small number is subtracted from the larger, okay, fine. So clearly I'm making x the bigger number. I'm making y the small number. Okay, fine. I want x times y. So how do I solve for x and y here? What can I do? substitution, or you can add up the equations, whatever technique you prefer. I think this is something we asked in our placement test that you guys took, about 3 years ago before you. Go ahead, Grace. Sure. Yeah, or 40-30. Sure. Or 50-20. Yeah. Looks like 50-20 will be the winner. Yep. Yeah, you could do a little guess and check as well. Yeah, because the sums and the differences were multiples of 10. That's good thinking. And then, of course, they want you to multiply those two numbers. 50 times 20 is 1,000. Right. Yeah, they love system equations. I don't think system equations is really a big thing we need to spend much time on. I don't think it's really, I think you guys are okay, but I did want to go over that problem. I'm looking at 11 and 12. 11, 12, 15. I want to go over those next. 11, 12, 15. Okay, yeah, and this is our fault. I know for a fact we cut this out from our curriculum in the spring of 2020, and we did cut it out last year from Algebra 2. And this was not covered in pre-calculus. This is our fault. The equation of a circle is this. And again, this is why I gave you guys a test. I need to know, we totally dropped the ball here. We did not teach this to you. So I got to teach this to you. That's the equation of a circle. It looks weird. It looks weird. You maybe learned in geometry, I don't know. So what's going on here? Let me give you a quick crash course on the equation of a circle. That's a circle, obviously. That's the center. The center we'll label as H and K. That's a point in the circle. I'll label as X and Y. The reason why I do that is because I want the equation. Remember, equations are relationships, right, between two variables. If I deliberately let a point in the circle be X and Y, then I want an equation that relates X and Y, right? Okay. What the line that connects these 2 points, what do we call that line? The radius. Totally, we'll call it R. I mean, it seems intuitive, right? And then let's draw a right triangle. Now, this part may not seem intuitive, but you'll see why I'm drawing a right triangle in just a second. I drew a right triangle. Let me call this side A and call this side B. Of course, you guys should know this. Pythagorean Theorem. That's something that's been being to you guys for the last 5-6 years. A is a horizontal leg, right? Isn't that the difference in the x coordinates? The length of that horizontal leg, isn't that just x minus h? If I just take the difference between here and here, that's the length of the horizontal leg. What about that vertical leg? That's y minus k, right? And voila, there's the equation of a circle. It's not a tricky derivation. If you could see it that way, you're never, ever going to forget this. It looks a little intimidating because you have 5 letters and you have a lot of symbols. It's really not. It's just really just Pythagorean theorem. So now the center is 0, 0. The radius is 4. I got the answer. It's C. That's all. Again, you can memorize the equation of circle, but I think it's better to understand why it works the way it does and just apply what they want. And again, I'll give you guys practice on this, so it's drilled into you guys. 12 was interesting. I know that you guys, first of all, just a show of hands, who had Algebra 2 last year? Okay. I know that they rushed some things. And of course, I think, and I know if you had Algebra 2 the year before, I think it's probably worse because we deliberately cut stuff out. But I know that this concept was rushed. Here's all you have to do. Well, first of all, let's just backtrack a little bit. What if I have 4x cubed squared? What does that mean? That means 4 squared times x to what power? 6 power. Not to the 5th power, to the 6th power. So x cubed twice. X, 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 x. That's 6 x's, right? So that's 16x6. So I'm just going to say, who cares if a fraction? Just do the same thing. 16 to the 1/2 times x to the 9/2 times y to the 3/2. So I definitely want x to the 9/2. So and y to the 3/2. That only leaves me with e. And that's it. Done. What's happening with a fraction exponent? just a little refresher, that means square roots, just so you know. Anything that's like x to 1 over n power is a root. That's purely conceptual. They're testing you on that knowledge. So that's why you get 4 and then all the other junk. So that's 12. Definitely want to talk about 15. Actually, I want to talk about 14 first. 14, we have never taught you guys. I don't know where we would throw this into our math curriculum. Personally, I think it's kind of cool because I do a lot of statistics. I think it's kind of good to know. We have to read the whole thing, unfortunately. It's a lot of dense material, but we'll have to read it. Determined cooking with olive oil reduces the risk of heartburn for men. Researchers interviewed a random sample. Okay, random is good. That's going to do random. I'll explain why that's important just a little bit. 5,500 men who had no history of heartburn, okay? Study participants were identified as either regular or occasional olive oil users. Okay, so there's 2 groups. Use olive oil maybe every day, or maybe they have olive oil maybe once a month or something like that. 5 years later, they interviewed the men again, and they probably asked, hey, or they found the portion of men who experienced frequent heartburn was lower for men identified as regular. So they basically asked, hey, do you have heartburn? And I guess the men who had olive oil on a regular, maybe they cook with olive oil every day or something like that, they have as much heartburn as those who don't. Okay, fine. So which of one is the most appropriate conclusion of the study? Okay. So this is what we call causation versus correlation. So say, for example, if I were to say, if you sleep 8 hours, the more hours of sleep you get per week, the higher your GPA. But that might make sense, perhaps, if you're more well rested. Or I mean, actually, I think there are a lot of people on that. I'm just throwing a number out there. So does that cause? So does sleeping more cause your GPA to go up? There might be other reasons why your GPA went up, like maybe, you went to, you just took your studies more seriously, maybe you hired a tutor, maybe you found a good study group, maybe you're just taking school more. I don't know. There's a lot of different ways that maybe you took easier classes. I don't know. But is there a correlation? Yeah, absolutely. There's a correlation or an association. So correlation / association, those kind of mean the same thing. So you can't say it causes it. That's just way too bold of a statement. So the word cause kind of kills A and B. We don't know for sure. Now, why is D better than C? What kills C? Go, Grace. We didn't survey women. I don't know what's going to women. Yeah, exactly. Yes, I'll go D for that one. And the word association is a clincher there. But woman kills it for C, and of course causes. The verb causes kills it for A and B. So that's just a quick kind of crash course in causation versus correlation. Okay, let's keep moving here. Now 15. Yeah, we have to. So they have information that kind of pertains to multiple questions. Like this information up above pertains to 15 and 16. Let me read what this is all about. H is the height of an elephant, I guess, from its foot to its shoulder. Okay, and C is the circumference of its footprint. Okay, fair enough. So now it says if the wildlife biologist finds a circular elephant footprint has a diameter of 30 centimeters, which the following is the height of the elephant. Okay. Now, first of all, the diameter is 30. What is circumference, by the way? They give that to you. If you forget any geometry formulas, don't worry. It is given to you. It's all right here. Boom, 2 pi r. But they gave us the diameter, not the radius. I'm guessing some of you guys missed it because you probably said the radius was 30. The radius is not 30. The radius is 15. So they messed with you there. They totally messed with you. R is actually 15. Circumference is 2 pi r or pi d, your choice. Either way, circumference is 30 pi. So your height is going to be 3 times that amount. Because it said so in the equation, which is 90 pi. And then you can use a calculator. Pi is 3.14. If you do 9 times 3.14, you should get somewhere close to 300, 280, 270 something. So it's D. Actually, I'm not sure if you would ran into the wrong answer choice if you said R was 60, or sorry, R was 30. But anyway, let's take a look at the last. Let's look at 17 also. Actually, while we're at it, let's talk about 16. While we're at it here, the circumference of a mother's elephant circular footprint is 4 times the circumference of a baby. What's the ratio of the height? It's just gonna be the same thing, right? It's all linear because h over c is already a constant. So yeah. Okay, 17 exponents. Again, going back to advanced algebra, that's gonna be x to the 24a power. That's x to the 8th power. So 24a equals 8. A equals 8 over 24. A is 1/3. Done. That's all. Again, you multiply the exponents and you raise the power to a power, right? X to the 4 gets raised to the 8 power, that gets multiplied. X squared raised to the 4 power, xx, 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 8 x's, right? Set the exponents equal to each other because the bases are equal. There you go. I'm also guessing you guys might have been tired by this time too. So, 18, just solve the system. Just get y by itself, I suppose. And that one's going to be y equals x minus 5. You move things around correctly. Sum equal to each other and solve for x. And if x is -4, you do get -9, or if x is 3, you get -2. So that's going to be -9 for this one and -2 for that one. So yeah, so you obviously go with the one that you see in the choices. And also I think, yeah, there we go. Yeah, which is a y core in the solution. Let's talk about the last 3 here, 19 and 20, and then 21. And then we'll take a break after that. All right, 19. Remember I talked about y equals mx plus b. I talked about this, right? That's the same thing. You could just think of this as d equals -500t plus 2565. 2565, there we go. Because guess what? That's my y-intercept. That's my slope. And, you know, d is like y. D is y. T is x. So now what does 2565 represent? That's the y-intercept. Or basically how many miles you start with. That's probably the distance between the city in Pennsylvania and the city in Ecuador. So it's just going to be the distance between those 2 cities. That's all. Because he even said D represents the distance between the 2 cities. But obviously, as time passes, the airplane gets closer to the city in Ecuador, right? It gets smaller. So again, it's interpretation. Or for 20, how many hours will it take for the airplane to travel between the 2 cities? Well, obviously, D is going to be 0 once you get there. So that's all you need, plug in 0 for D, because now you're in this, you're in this city in Ecuador, right? So 500t equals 2565. And of course, you should use a calculator for this one. I think it's 5.1 something. Yeah, the answer is D for that one. I trust you guys to use a calculator to solve that one. But again, you just have to interpret the equation correctly. You know, how long does it take to get to your destination, it will do 0 by that time. All right, last one. This one also, we just don't teach it. I think scatter plots are great. I think we should be more data proficient. Hopefully maybe one of these days you start putting some in our curriculum. But you guys have probably seen in science class, so best fit line. So you're looking at the number of surveys, sent number of surveys returned, okay? So, and this represents 17, so every dot represents a neighborhood. Like maybe you send one to the neighborhood across the street, right? And so you send out 500 surveys, maybe get 400 back, I don't know. So that would represent a dot. Now, the question here is, the neighborhood that had sent 800 surveys, so it's this dot here, 600 were returned, right? So that's 800 sent, 600 were returned. So the question is, which of one is closer to positive between the actual number of return, which is 600, and what's predicted by the line? Well, what is it being predicted by the line? Looks like, oh gosh, that's hard to tell. Probably 450, I'd say, to be fair. So I'd probably say about 150, and it is A. But see, this is a question where you have to really be focused. And I do think at 6 o'clock on a Wednesday, after I had you guys do some reading and writing practice, and you're gonna go, you probably have some other stuff going on. This is why rest. I do think there's some questions, like for example, and I think this is gonna be more rest than anything else. Like if you're missing some of the questions in the beginning here, like what is the y-intercept of this line, or how to plug in 7 and 5. To me, that's just, we just need to do some review of algebra. You might be just rusty. But some questions just require an incredible amount of focus. You just got to really pay attention. And I think 21 is a good example of that. And that's why rest is important. I would strongly recommend, I'll be in touch with you guys, obviously, throughout the whole fall before you take this test. But yeah, I would say the best thing to help yourself out, like before October, like if you take this on October, I think 13th. Yeah, actually, that's 3 months from today, isn't it? Yeah, it'll be that's National Testing Day. I think we're gonna do it on the 13th. So you guys have plenty of time. You read this for a month. You still have 3 more months. But I would strongly recommend like those like starting that weekend of the 8th. Just start getting some good sleep. Start getting go to bed by 10, 11 o'clock. Wake up around 7. Great. And do that. And then even if you have like other stuff to do, if you don't get it done, that's fine. Don't stay up late. Don't pull all-nighters. I think that's really gonna be because you need that kind of that laser sharp focus for something like 21. It's not hard, just gotta pay attention. So, all right. So what we'll do, I'm gonna go pick up the packets. We'll do about a 10-minute break. Come back at 5:15. We'll do some more problems. I'll probably kind of handpick problems or similar to what you guys missed here, so you guys get some extra practice. Yeah, and so you guys can just feel free to roam around or stand here. We'll come back at 5:15.